Characteristics of functions. For each set of functions, give characteristics that the functions have in common and characteristics that distinguishes them. So I've made it more interesting this time. I'm taking 3 functions at a time. So we have 2 sets of 3 functions. The first one here is this set, which includes absolute x, exponential function 2 to the power of x, and parabola, the quadratic function x squared, right? These are all the parent functions. You need to find characteristics which are similar to all 3 of them and which are different for all 3 of them, right? Normally you're comparing 2 of them, right? It becomes kind of simpler. So now you need to do characteristics which are same in all 3 and which are different in all 3. The next set of questions here is a linear function f of x equals to x, reciprocal function h of x equals to 1 over x, and the trigonometric function the sine x. So you have to do the same for this set of functions, right? So that makes the question very interesting, correct? Now let's look into it. So try to get this answer and then look into my suggestions. Now what do you think is similar for all in the first set, that is absolute function, the exponential function, and the quadratic function? Let me first sketch them. So let me first sketch all of them here so that it becomes easier for us to analyze, right? So we'll sketch them first. Absolute function is like this. Exponential function is like this, right? And parabola is like this. Now how are they similar? Now once you sketch them, it becomes easier, right? So similarities we can write now. So how are they similar? One, of course, is the domain, right? You see domain? They're all continuous functions, and so the domain for each is equal to x belongs to real numbers, right? So that is one similarity. And that's a good similarity. They are similar in their domain, right? What else do you observe? How else are they similar? So you'll also observe that they are non-negative, right? So we can write non-negative. So why am I writing non-negative? Since this function is not 0, right? So I could have written all of them positive, right? Or I could write something like that regarding range. But range is different in these functions, correct? So these could be 2 where we can say, well, they are similar. We could write more. So we can say they are in quadrant 2. So they are in quadrant 2 and in quadrant 1. Do you see that? That is also similarity. So they don't really get into quadrant 3 and 4. They are in quadrant 2 to quadrant 1. They actually move from quadrant 2 to 1. Do you see that? So these are the set of similarities which you can find in these functions. It's very, very interesting and very important for you to know. Once you know this, then you can always find similarities when 2 of the functions, right? Now let's find how are they different. Isn't that wonderful? Having 3 at a time, how are they different? Now this is a very, very difficult question to answer. How are they different? Now as far as the difference is concerned, how is the nature of the curve? That could be a difference, right? Here it is kind of a straight line, right? And here it is always increasing, and here it decreases and increases, but it's not linear. So that could be one behavior, right? The nature of the curve. So differences in the curve. So the first curve is a straight line decreasing and then a straight line increasing. And the second one is always increasing in a curve. And the third one is decreasing curve nonlinear and increasing nonlinear. Now this could be described in a much better way, and that is slope of tangent, that is rate of change. So if you find slope of tangent along this curve, what do you find? It is -1 and then +1. Do you see that? And it is undefined at origin. We don't know what it is at origin. But we know in quadrant 2 it is -1, in quadrant 1 it is +1, and it's undefined at 0. So the other is rate of change, or you can say slope. Slope is different for all. Here the slope is always increasing. Do you see that? Slope is always increasing. It goes from 0 almost to positive and more positive. And in this case, as far as slope is concerned, so let me write slope here itself, show you how it is different. So slope is -1 here but +1, right? Slope is increasing, so always increasing. And it is positive. Do you see that? It goes from almost 0 to positive. But in this case, the slope is negative on this side and positive on that side. Do you see that? With undefined here. So that is how they're different in their slopes. Correct? So that is one which we could explain the difference between all the three. And the second is turning point. If you see, here we have a corner, right? So in the first case, we have a corner. In the second case, there is no turning point, right? Does not have any turning point, no turning point. And in the third case, it is smooth turning. Do you see? Not a corner. So it's a smooth curve. Not a corner. It makes a difference. If it is not a corner, then the slope is 0 here. Do you see that? So it changes from negative. The slope changes from negative to 0 to positive. Do you see that? Because the turning is smooth. In this case, since the turning is with a corner, the slope is undefined. So that could be another difference between all three of them. Correct? So that is how you can write similarities and differences between three functions taken together. Now, answer the next set. So follow the similar approach. Sketch them. So this is a straight line, right? This is 1 over x, correct? And this is sine x, right? So once you have these functions, how are they similar? Giving a similarity here is the most difficult process. I mean, differences, there are so many. Similarity, let me write down one similarity. How are they similar? One similarity is that they all are odd functions. If you miss this, then it's very difficult to answer this question. So they all are odd functions. That means f of minus x is equals to f of x. And that also means they are symmetric about origin, right? So if I plot this, then they are symmetric about, they should go through the origin, right? Symmetric about origin. So they all are odd functions. So that is a similarity difference, right? As far as differences, you can give many. And one of the good difference could be in the range. So this range is from negative infinity to positive infinity. Here, the range is from negative to infinity to positive infinity, but does not include 0. Do you understand? And here, the range is between +and -1. Do you see that? So it is between +1 and -1. So the range in this particular case is that g of x is less than equal to 1 but is greater than minus 1. So the major difference here is between the range. Of course, in the domain you can say, but domain of these two are similar. That is why it is not different in all the three cases, right? So these are the differences and similarities between these functions. I know you can find many more, right? So figure them out. But to bring to your notice that try to see three functions at the same time and find similarities and differences between them. At times it could be challenging. I hope you find it interesting. Thank you.